quickly. I have used this presentation for other project. So guys, let us quickly go for the SIL overview. I will take little time to just explain what is the SIF. As you know that to qualify the definition of safety instrumented function, we need basically three elements. Three elements are very important to qualify the safety instrumented function. So likewise, we will see in our workshop, and you, me, and entire team will decide whether this is a SIF or not SIF. If this is SIF, we will deliberate. Just to answer you, we have identified the SIF from the HAZOP, but for awareness point of view, we must have a sensor. If you see on the left side, there is a one camera is there. So this is the initiator for any event. And after that, this sensor will give the signal to the logic solver. So based on the sensation, based on the set point, it will give the signal to logic solver, and the logic solver will process the information and it will give a command to final element as per the set point, as per the operation control, as per the emergency function. So in nutshell, any safety instrumented function should have a sensor, should have a logic solver, and should have final element. I'm not saying something new. You guys are very well familiar, but I just wanted to explain so that we are on the common forum. Now, what is the objective of SIL study? Basically, we need to identify all the SIF in the scope, and we need to define the safety integrity level of that SIF, because in case of any emergency, that safety instrumented function must be working. So what is the purpose? Purpose is to define the SIL rating to meet the targeted mitigated event likelihood. What is TMEL? I will take little more time to explain the TMEL in the next slide. And the basis of that, we will determine the safety integrity level after identifying the all initiating events, and we will take credit of all IPLs, relevant IPLs. What is IPL? I will again take little time to explain. Basically, for the SIL assessment, there are various standards internationally recognized. We are going to use IEC 6151508. Guys, any question for me?
No. Proceed.
Okay. And there is another recognized standard is IEC 61511. And of course, ADNOC has got beautiful standard and system HSERM ST05, which is dedicatedly informing the methodology and the approach, how we need to identify the safe SIF, how we need to evaluate the TMEL, how we need to evaluate the consequences, how we need to identify the conditional modifiers, and we will take all the initiating events, and we will identify the initiating event likelihood, and of course we will identify all the IPLs, and then we will give the PFD of the IPLs. So guys, this is a very simple steps. So first of all, we need to identify all the SIFs from the cause and effect. So to be honest, we have done this process, during our alignment with the help of our team from NP. And we will also take the help from the HAZOP, because HAZOP was done for this scope. And after that, we will identify the worst case consequences, because we should be ready for the worst case consequences. What is the worst case and where we will get the worst case? The worst case has been already identified in the HAZOP session. So I would encourage, let us not touch the HAZOP. Let us take all the inputs from the HAZOP straight away, and let us not challenge the HAZOP consequences until and unless you feel that the HAZOP team has not done the justice. I would always encourage to stick with the HAZOP outcome. If you feel the HAZOP have missed something, then I'm happy to correct the HAZOP so that we don't miss any critical scenarios. After that, we will identify the tolerable or target mitigated event likelihood, that is TMEL. So in HSERM ST, in the terms of reference, we have identified the TMEL as per the ADNOC standard, and we will take the help from the TMEL table. And of course, we will identify all the initiating events from the HAZOP. If we feel that some initiating events are missing in the HAZOP report, we will again correct the initiating event in our session, but we will not touch HAZOP. And after that, a conditional modifier will take into the credit. Enabling events are not applicable for oil and gas industry. These are applicable only for a nuclear plant, aviations, and other kind of reacting plants. And of course, we will identify all the IPLs, and we will take the credit of all the PFD of the IPLs, and then we will calculate the RRF risk reduction factor, and then basis of RRF, we will define the safety integrity level. So I hope this step is very simple and you guys are familiar. If you have any question, any point of time, please feel free to ask to me. If I have the answer, I will definitely come back to you. So guys, if you see this table, I mean, we will start from the bottom. If you see the first column, this is SIL value. The bottom of the SIL value is a SIL 1. SIL 1 has got the target, I mean, probability is 10 power minus 1 to 10 power minus 2. The RRF is 10 to 100. So that means when the RRF comes to 10 to 100, it will automatically qualify SIL 1. If the RRF goes for 100 to 1000, so it will go for 10 power minus 2 to 10 power minus 3. It is SIL 2. When the RRF goes to 1000 to 10,000, it is qualifying SIL 3, 10 power minus 3 to 10 power minus 4. And the last but not is SIL 4, which is not applicable for oil and gas industry. That means in our design, if we get SIL 4, that means we have to redesign, we have to rethink for the technology, because this is not acceptable in oil and gas industry. SIL 4 is applicable only for aviation, only for nuclear plants, only high risk taking industry. So that means for our scope, we are going to work for SIL 1, SIL 2, and SIL 3.